Let us discuss a question from theory of machine. A refrigerator unit of mass 30 kg is to be supported by 3 springs of stiffness. So basically you have a refrigerator unit which we will model as a block of mass m, and it is supported by 3 springs. Okay, so obviously it will be a parallel support. See, springs in parallel, each, let's say they have a stiffness k, and okay, and effectively let's say they have k is what we need to find out, but effectively let's say kt is the total stiffness. Now obviously this will have a refrigerator has a motor because it has to run a compressor. Okay, so now the motor actually will be having unbalanced masses, and that's what and always the unbalanced mass, let's say for the motor, will be something of mr omega square. So it will be of this type, right? Okay, generally. So what is given is the unit is operating at 580 rpm. If only 10% of the shaking force is to be transmitted to the supporting, so whatever is produced due to unbalanced, only 10% has to be transmitted to the bottom ceiling, where to the bottom structure on which the refrigerator is kept. So what we do is, when we model this as a 1D system with forced vibration, this is the equation: mx double dot plus cx dot plus kx is equal to f naught sine omega t. Okay, this is the equation to model the refrigeration with forced vibration, where f naught sine omega t is the unbalanced force. Okay, so that is it. F naught is this r omega square, more or less. Okay, f naught is that. Okay, so unbalanced force. Okay, so now when we derive the equation of the transmitted force, what we do is, if you remember, the transmitted force, okay, the transmitted force here is kt, is by the help of a spring, so kt into the maximum amplitude which you can get. And the maximum amplitude, we know the expression of the maximum amplitude. It is basically, when you have a forced vibration, it's f naught by k. I'm just writing out the maximum amplitude equation: 1 minus omega square by omega n whole square, complete whole square, plus 2 xi m omega n by omega n. Basically it is 2 xi omega n by omega n whole square. Okay, this is actually the equation: 2 xi omega n by omega. Now thing is that we don't have any damping here, so xi is 0. That's why the transmitted force is kt into a. Otherwise it will be, if you have a damper, then again c into a dot. So that's okay. We don't have a damper, so this term will just go to 0. There's a square and a square root, so that gets cancelled. It's f naught by kt. Okay, the total stiffness. So kt's get cancelled. So it's f naught by again, because of the square root, so we take omega square by omega n square to be positive, minus 1. Okay, it can be 1 minus also, but we generally we have omega greater than okay, so you can try even that case also, but here we will restrict our discussion to omega square by omega square and minus 1. And here you have ft. Now the transmissibility ratio, that is only 10% is transfer, that is ft by f. So that is actually 1 by omega square by omega n square minus 1. Now this value is basically only 10%, so it is 0.1. Okay, so from this what I can get is omega square by omega n square will be 11, and I need to get omega n because omega is given. Omega is 580 rpm, so that is the forced vibration frequency, and so I convert into radians per second. So 2 pi n by 60, 2 pi 580 by 60, and from this what I get is omega. I need to get omega n, so omega by root 11 will be omega n, and omega is I get from this equation. So when I substitute here and divide by root 11, I get 18.3 radians per second. So this is my omega n, which is natural frequency. Once I get the natural frequency, because I am modeling it as a simple spring mass system, so omega is root over k by m, natural frequency, root over kt, because kt is the effective friction. So kt will be 18.3 whole square into mass is 30 kg. So this, when I multiply, I get a value of k as 10046 Newton per meter. Now I have 3 springs, so kt will be 3k, and I need to find out, so this is 10046, so k will be 10046 by 3, so which is 3349 roughly, okay, Newton per meter. So 3349 Newton per meter. So this is just a sample example for the forced vibration case. Okay, so you have to always see what is your transmissibility force, and then the ratio is Ft by F naught. Okay, means the applied force amplitude and the transmitted force amplitude. Now applied force amplitude is F naught and the transmitted force amplitude will be Ft. So Ft by F naught is what is your transmissibility ratio, and that ratio, when you don't have any damping, will produce 1 by omega square omega n square minus 1. So this value. Okay, so basically we have derived it, otherwise you can use directly if you remember it. So thank you.